So today we're going to talk about compound inequalities. And don't get worried, they're not that hard. And you solve them just like you would solve a normal inequality. What happens is you have two different inequalities that are joined by the word or, as in like this or that, or they're joined by and, which means blank and blank. So the only thing that's going to change with compound inequalities is the way we graph them. Because we're going to have, say, x less than 2 or x greater than 5. So we're going to have to graph each one of these separately. And for this one, we could have x is less than -1 and x is less than 2. Which means both of these things have to be true. So we graph ands a little bit differently. But the best way to really explain it is to just go ahead and do an example. So this is our first compound inequality. And what you need to understand is that these two things, when they're joined by this or, make one problem. So we're going to solve each inequality separately, and then when we graph them, we're going to graph them together. So for this, we would do like we usually do. We would subtract 3 from both sides. We'd get -4a less than or equal to +2. We divide by -4. We would get a greater than or equal to, because remember you got to flip the sign, -1/2. And then we're going to write or in between. And we're going to solve this inequality. So 5a is less than, if we subtract 1 over, -5. Divide by 5, divide by 5, a is less than -1. Now, if when you solve this, you get a is greater than -1, then you didn't realize that you only divided by +5. You didn't divide by -5. Just because you get a negative answer doesn't mean that you have to switch your sign. So when we graph this, first we're going to plot our points for each one of these. So this is a greater than or equal to -1/2, which I'm just going to have to estimate and say that -1/2 is right here. So I'm going to put a circle around that, and then a less than or equal to -1, which is going to be close to 1/2. We'll say like right there. So since I have a greater than or equal to, I'm going to have a closed circle over -1/2 and an open circle over -1. Now, if you look, you have to make sure you match your inequality up with the right point. So you have a less than -1 and a greater than or equal to 1/2. So that means that this, you're going to have an arrow going this way for all your a's that are greater than -1/2, greater than or equal to -1/2. And you're going to have an arrow pointing to the left for all a's that are less than -1. So when you plug in your numbers for each one of these, you're going to plug them in separately to check. So we're going to do one more example, but this time we're going to use an and compound inequality. So again, we're going to solve both inequalities like we normally would. So we're going to subtract 3 from both sides, get -1 less than or equal to y. So I always like to write my inequalities with the variable on the left because that's how we graph them. So this is y greater than or equal to -1. Now if you look, I didn't change anything about this inequality because this inequality says that -1 is less than or equal to y. And this inequality says that -1 is less than or equal to y too. So I'm going to write my and down, and I'm going to solve this inequality separately. So we subtract 3 from both sides, and we get y less than 2. So first thing we're going to do is plot our points. So 2 is about right there. Negative 1's about right there. And this one's greater than or equal to negative 1. So we're going to have a closed circle. Now, this and right here is going to join these two inequalities together. And we're going to shade the area in between these two circles. And because and means the same thing that it does when you're talking. If you say that I like blue and I like red, it means you like both of them. So if this means that, so when you say that y is greater than or equal to negative 1 and it's less than 2, it has to fall somewhere in this region between negative 1 and 2. So that when you graph your inequality for an and, you should always have a little shaded area between. And if you notice, with an and, you cannot have the same inequality symbol. Because if I had y greater than 5 and y less than negative 3, that could never happen because look, 5's all the way over here, negative 3's all the way over here. There's no way that it could be greater than 5 and less than negative 3. So when you graph compound inequalities, you have to make sure that you pay attention to this word that joins them together, because that's going to determine how you graph it. So that's all we're going to do with compound inequalities. And make sure you come back and watch our next lesson where we're going to switch focus a little bit and start talking about exponents.